I welcome you all, dear students. During these classes, we are learning some of the techniques to solve some of the problems which are for simple harmonic motion. And here it is. It's the fifth problem of this topic, that is simple harmonic motion. A body of mass m suspended from a spring with constant k vibrates with frequency f2 when its length is cut into two halves and the same body is suspended one of the half. The frequency of is f2. Find first it was f1 and the frequency is f2. Find out f1. Ratio between the two frequencies f1 and f2. You have to calculate f1 as well as f2. So if you look at, this is the mass attached m, spring constant is k, frequency of the whole spring is f1, frequency of the half is f2, this one is f1. So the displacement of the whole spring is x1. Displacement for half spring is, we are dividing the whole into two half, that is x1 divided by 2. So formula to calculate frequency of the mass which is attached with the spring, that is, but time period is 2 pi root m over k. If you take the inverse, then it is frequency, and frequency is equal to 1 over 2 pi root k over m. So at the same time, following the Hooke's law, this force is directly proportional to displacement, and it is equal to kx. If you compare these two, you are getting formula 1 over 2 pi root m mg over x. Correct? And after getting the value, its frequency is 1 over 2 pi g over x. And if you look at, this is f1, then it will be 1 over 2 pi root g over x1, and this will be the frequency of the whole thing. Then when you have broken into two pieces, then this will be the frequency f2, 1 over 2 pi root g over x2, and this x2 is equal to basically half of the actual amplitude of that mass. So if you put the values, you are getting, you got f1 and f2. Here it is f2, here it is f1. You have to take the ratio between the two. This is basically f2 is root 2 times of f1. So it's f1 divided by f2, 1 over root 2. And after putting values in the formula, we are getting the ratio between the two frequencies. What was the question? Body of mass m suspended from a spring with a force constant k, spring constant k, and vibration of the frequency at that time is f1. When its length is cut into two halves and the same body is suspended from one of the half, then the frequency will be f2. Find out the ratio between the two. First we have calculated f1, then after application of the condition we have calculated f2. Finally we calculated the ratio between the two, and this is the ratio between the two. Thank you very much for your patience.